Welcome to the 5 pillars of AI evaluation metrics. It's entirely possible to build an AI model scoring near perfect accuracy on a technical benchmark, only to watch it fail spectacularly in production. High latency, subtle algorithmic biases, or unsustainable cloud costs can quickly break a system that looks flawless on paper. To successfully commercialize an AI product managers have to look past the top-line benchmark scores. You must build an evaluation stack that connects the mathematical health of the model to system efficiency, ethical safety, user experience, and ultimately business impact. This evaluation stack requires 5 distinct layers of measurement. We have to construct this framework layer by layer, evaluating the system at every stage of its lifecycle, starting deep within the mathematical weights of the neural network and moving all the way out to the end-user screen. Think of this as an architectural exercise. You cannot scale up to business reality without first securing a foundation of mathematical truth. We begin at the base, Layer 1, the Model-Centric foundation. This determines if the AI engine is mathematically sound for its specific task. For traditional classification tasks, we use rigid evaluation metrics. We measure accuracy, precision to minimize false positives, and recall to minimize false negatives. When dealing with imbalanced datasets, we rely on the F1 score to find the balance between the two. If the model is performing regression, we track the exact magnitude of its prediction errors using mean absolute error and mean squared error. Evaluating generative AI requires a different approach. Instead of deterministic labels, we measure the model's probabilistic confidence, a metric known as perplexity. Low perplexity means the model is highly confident in predicting the next token. High perplexity indicates confusion. For summarization and text generation, we track quality using ROUGE and BLUE scores. Crucially, we also monitor the hallucination rate to catch fabricated outputs and measure faithfulness to guarantee the response aligns exactly with the source data. Passing these modality-specific benchmarks proves the model works in a vacuum, but mathematical correctness is only the first hurdle. Moving up the stack, we hit Layer 2. A technically perfect model is useless if it cannot operate efficiently at scale. We have to track response time and latency. For generative models, this means measuring the exact time it takes the system to process a request and generate the very first token. Alongside speed, we monitor throughput, the total volume of requests the system can handle simultaneously, and precisely track the cost and token usage per query. Maintaining these unit economics is vital. If an AI is too expensive to operate sustainably or too slow to keep users engaged, the product fails. At Layer 3, we track the metrics required to secure brand trust and regulatory compliance, responsible AI. Here, we evaluate qualitative requirements like explainability, ensuring the AI provides checkable source citations for its decisions, and fairness, to guarantee unbiased, equitable treatment across all human demographics. This visualization illustrates the inevitable degradation of AI in production. On the left, data drift occurs when the statistical properties of real-world inputs change over time. On the right, model drift is the consequence. Prediction accuracy drops because the learned relationship between the inputs and targets is no longer valid. To catch this early, we track the Population Stability Index. It acts as a statistical alarm system, signaling exactly when the machine learning algorithms require retraining. Without strict governance and active drift monitoring, an AI system will slowly erode its own predictive value and introduce immense liability to the organization. Next, we measure how human beings actually perceive and adopt the tool in Layer 4, User-Centric metrics. We quantify real-world engagement by checking user satisfaction scores like CSAT and NPS, tracking daily and monthly active users, and logging session duration to see if the AI holds their attention. Ultimately, this layer tests value by tracking 2 opposing forces, the customer conversion rate against the customer churn rate after their initial experience. If the underlying model is mathematically sound, fast, and safe, but fails to retain users once they try it, your product strategy has failed. Finally, we reach the apex of the evaluation framework, Layer 5, Business Impact. This is where we calculate the financial justification for the product's existence. We measure the return on investment by balancing financial gains against the heavy costs of development and inference. We track direct revenue generation, such as monthly recurring revenue, and calculate the competitive edge gained through accelerating the company's time to market. Every metric sitting lower in the stack exists solely to enable and protect this top tier of business viability. True AI product management requires balancing all 5 of these pillars simultaneously. Optimizing a generative AI model's perplexity at layer 1 is ultimately a wasted effort if the inference token costs at layer 2 destroy your recurring revenue margins at layer 5. To master the full lifecycle of AI products, from foundation models and RAG architectures all the way through to go-to-market strategy, you need a comprehensive playbook. Step up as a next-generation product leader. Subscribe to the AI Product Management Playbook by Deepak Deo on LinkedIn and start building AI products that deliver real impact.